Okay, my clock says it's 12 noon. I'd like to welcome everybody to our monthly Iowa State Extension and Outreach Dairy Team webinar series. Today's program will focus on climate and weather predictions for the 2025 growing season. And our presenter today will be Dr. Dennis Todey. He's the director of the USDA Climate Hub in Ames, and we'll talk about climate and weather. As I always say to our presenters, Dennis, the podium is yours.
It's funny, Fred. I don't feel a podium here in front of me. But anyway, thanks for having me. Always appreciate getting a chance to get out and talk with people from a standpoint. Getting out in this case is a relative situation, but always happy to be here. If you've done been in my presentations before, you know that I like them to be as informal as possible. So I really do like engagement or asking questions along the way. I'm struggling a bit because I ended up hiding my taskbar and I can't get it pulled back up and I can't see the chat. So I'm gonna have to fly blind, unfortunately, related to this. I've been trying to mess around and I can't get it back for whatever reason. But at least you're seeing my slides, so there's that part of it. So I think we're small enough. If anybody has any questions along the way, please do interrupt me, shout them out. I'm always happy to divert or move, to move in a different direction as we need to. So just a little bit more about me. I'm originally an Iowan, originally from Southern Iowa, the area where not as many dairies down there, and actually not just some livestock and not a lot of crop production because the area I was is very Missouri-like, lots of clay soil. So the agricultural production was not the greatest down in that area. So and further, the connection I had to agriculture growing up was my dad worked for the big green company in Atumwa. So I really didn't have much of an ag connection beyond that until I started getting into my PhD and kind of decided that I wanted to connect ag with weather and climate issues. So, and then it's been uphill or downhill, depending on how you want to look at it from there. So let me pause there for a second. Is there any questions anybody has about weather, general weather or climate issues, ag or whatever that they'd like to ask off the top? I'm more than happy to address those right away.
For those who are interested, just go ahead and unmute and ask the question. Or if you want to put it in the chat, I'll monitor the chat, Dennis.
Thanks, Fred. I'm feeling stupid. I don't know why I can't get that back to me. Anyway, so okay, not seeing anything overall. Again, we also have a couple of my staff who are joining me here today, who helped create some of the slides, and so they can chime in and comment and tell people what I'm really supposed to be saying compared to what I am actually saying. So we'll do again a little bit more about the Climate Hub, who we are, a little bit more on a couple tools, and I'm going to throw in some slides on. We're going to talk about corn sweat a little bit today, and then we'll get to the outlook related information as we're going along here. Again, everything I have is publicly available websites, so you can grab websites off here, or I can share slides with you later on if you want to try to get them afterwards. Quick reminder who we are. We're part of USDA, part of the Agricultural Research Service, housed on campus in Ames at what used to be called the Soil Tilth Lab, the National Lab for Ag and the Environment. We officially cover an 8-state region that is most of the Corn Belt, Minnesota to Missouri, over to Michigan and Ohio. And but then we do expand what we do because we work with row crops. We expand out into the plains a little bit and then down into Southeast because some of our partners cover Kentucky, some of our partner organizations cover Kentucky, even though we officially don't. So we cover those, help cover those bases as much as we can. And what we see here, this is the way we count our beans, the kinds of things that we do, because we need to track what we're doing and always looking for information. So if something we provide today is something that you find really interesting and useful, and you do use it, we'd like to know about it. Not to follow up on you, but we always like to share information about how we're helping impact weather and climate and ag issues. We got a good story a couple weeks ago, a soil temperature tool, or excuse me, a freeze date tool that we've developed a couple of years ago, and I think I've talked about before. NRCS in North Dakota was using it in their cover crop recommendations, and we were very excited that someone was helping incorporate some of the things that we're doing into this issue. So I'm going to go ahead and jump past the tools here. I think we've talked, well, I guess let me introduce this one. This one is a little bit newer. We've not seen as much previously. When we talk about temperature and precipitation and things related to climate, we have climatologies of certain things that we measure. Temperature, precipitation are two of the big ones. Other things we don't have as good of measurements over a long period of time, so it's hard to develop what we call climatologies for them. So we approached a couple of years ago, we approached the Midwestern Regional Climate Center and said, hey, we've got some issues with people making decisions related to soil temperatures. Some people who fall applied nitrogen or planting decisions based on, they're doing practices that are not in the most optimum conditions, usually related to temperatures, what's going on around 50 degrees. So we approached them and said, we need to develop a climatology so we understand more about average temperatures during the time of the year. So in this time working with them, we've developed a soil temperature climatology based around the date on when we reach 50 degrees for the first time in the fall and stay there, and the date when we reach 50 degrees in the spring and when we stay there for that point, because those are kind of important things to know about for decision making in the spring and fall. So what you go in, and this is an earlier version, it's not the most recent version of this because we've updated the interface to it a little bit. This one shows when we reach, on average, that 50 degrees Fahrenheit at, in the fall. The day or the colors are up at the top there on when that happens. So the pinkish ones are, the end of September. Most of northern Iowa here is the last 10 days of October, or the first 10 days in November if you're across the southern part of the state. So that gives us an idea when we reach that level. And let's see, let's pop in here. So, and that's really what we've focused around trying to do that. We've also done it with freeze dates, though freeze dates are a lot more variable. We're going to talk about freeze dates and or freezing soil temperatures here in a bit, and what's related to this overall. So go ahead and check this out when you get an opportunity. There have been some updates. We now have time series. You can go into each one of these little boxes because this is, again, a gridded data set. It's not based on observations because we don't have good observations for a long enough period of time all across this region. So this is a bit of a synthetic data set, but it does give us something to work on. The other thing that it really did for us is it gives us some information in some of these forested areas up around the Great Lakes. We measure soil temperature in ag areas for important reasons, but there are also issues related to forest management that we now have some guides on up around this area. So it's helped us in a couple different ways on both sides of the house. Another part of the hubs are, we have a sister hub and I should go back and do that. I mentioned our region. We are part of the Ag Research Service. We share responsibilities in our region with the Northern Forest Hub, where they deal with the forestry side of the house or managed or other managed landscapes, not row crop per se. So they have more of an expertise in that area, and so we complement each other very well that way while working on some additional cross hub activities. So just a bit about that. Go ahead and check that out when you get an opportunity. Okay, now we're getting into an area that there's been a lot of discussion about, and we know the basic ideas behind it, but it still keeps coming up in the media a lot. So I just wanted to share some information about it. Taylor Schillerberg was one of the couple people who did a lot of work behind this, putting these together. People have heard the term corn sweat frequently. It's been around for maybe close to a decade now. I'm not sure exactly where it came from, if there was a paper that talked about corn sweat, or if it was a media term that grabbed on that, and it won't go away, unfortunately. So when, whenever very humid conditions come around, this comes around in the media. So we're always trying to explain this to people. So I wanted to throw a couple things on it just from a definition standpoint, and then understand how it is an impact related to weather and climate issues and what's going on. And also an issue related to livestock, how we manage livestock and how they deal with some of these issues. So, the basic idea of corn sweat is someone co-opted this and said, we're going to call it corn sweat instead of what's actually called the scientific term. If it's coming out of a plant, it's called transpiration. Part of the photosynthesis process, when the stomates are open, that are releasing oxygen, taking in carbon dioxide, there is transfer of water through that plant if the water is available. When plants are stressed, they will start to limit that transpiration and limit the photosynthetic process, because the plant is stressed and there's not enough water available. So that's another part we're going to talk about here. And usually when we talk about this, we call it that we can combine two things called evaporation and transpiration. We'll talk about that here in just a second. And there are a number of different pieces of information that affect how a crop transpires, how much water is being used by a crop. Is there water available in the soil? The crop type and variety and condition. Because if you have a very healthy crop with lots of water available, it's able, and there's lots of water in the soil, it's able to extract that water and transpire it into the atmosphere during its photosynthetic process. If the crop is stressed by something else, diseased or something like that, where it's not able to access the water, that will affect it, and also by time of year. Also, the temperature conditions, the humidity in the air, wind and solar radiation also play a role in how much water is being used by a crop. Temperature, obviously, if a crop is heated up and its leaves get heated up, and the one thing that I didn't put on here is I guess I did here, with solar radiation, with sunlight. When the crop is hotter, it's going to need to transpire more water as part of its process. If the lower the air, the humidity in the air, the amount of moisture in the air is low compared to the leaf, because the leaf, right at the leaf is about 100% relative humidity, so it's about saturated at that point. So the drier the air is around it, and this is where the wind also comes into play. If the wind is able to move across that leaf and move that water away, that also increases the crop water use. And then the solar radiation also kind of plays into temperature. So those all play a role. And sometimes the opposite happens when you have very warm conditions, but we have a lot of moisture in the atmosphere already. That limits the crop's ability to transpire water or move water out of, move water into the atmosphere. And in some cases, that actually can be a benefit to the crop, because the crop is not stressed as much if the water is limited. So those all kind of come into play related to this. Now, the other part about this is we combine ET, evaporation and transpiration, because we can't always tell the difference as to where water coming away from a surface is coming from. If it's coming from a bare soil, like in the springtime when you don't have anything growing actively, anything coming off that surface is going to be purely evaporation. In early growth stage, for whatever the plant is, it's going to be some kind of combination of that. And then when you have a mature crop, Most of it is transpiration. If the plant is canopied, it's almost all transpiration. If there's some opening in the canopy, you can get some evaporation combined with transpiration. So we usually just combine those two and put it all together. We don't try to separate it too much overall. And here's how that climatology works out during the year. The x-axis here is the days after planting, starting at 0 up to 150. And then the axis on the left-hand side is inches of water, how much water a crop uses on a day-by-day basis. So the green bars are the plant transpiration, and then the blue bars, or the blue here, is evapotranspiration, where you combine evaporation with transpiration. And this kind of gives you an idea of, again, there's a lot of variability around these days because the conditions are going to differ day by day. But the total amount of water coming off a surface is usually less than 1/10 of an inch until you get an actively growing plant. And then you get some combination of that. I believe this was corn, and in this situation, so that by that mid-season time period, that July time period around tasseling, is when a crop is using most of its water, and it's using 2/10 of an inch to 2/2500ths of an inch a day of water, and then gradually that starts to work its way down in the later reproductive periods. If we were to show soybeans, this would be shifted a few weeks later in this. And I was just corresponding with them. I think we got some information for alfalfa would be important to know too. I just didn't get enough chance to pull that in. Now, while that is happening, so locally we do have a source of water, because corn and soybeans, as people know, are very effective at transpiring, putting a lot of water in the atmosphere. But they don't create the water. They're only extracting water that's in the soil. So the water here has to come from another source. And in most cases, our source of water is the Gulf of Mexico. We're going to leave that right there, the Gulf of Mexico. In the areas of low pressure, these low pressure areas are storm systems with this counterclockwise circulation, bring water off the Gulf northward. And that's when we have our bigger rain events, when there's lots more water available that can produce rain. This access is why we actually have a very productive agriculture in where we are, because we are able to bring water up to the middle part of the continent. If we were not able to do that, the middle part of the continent would be much drier than it is. And that's also why, as you go quickly to our west, conditions dry out on average as you get into the plains, because it's harder for water to get from the Gulf of Mexico up into those areas. We can get Pacific moisture over periodically, but it's much harder to get over the mountains, so we don't get that much Pacific moisture brought over us. Most of it comes from the Gulf of Mexico. So that combination, and people, some research papers and some of the media is always, well, we're so humid because it's all corn and soybeans. Corn and soybeans are effective at putting more water into the atmosphere, but the water of the Gulf, there's also this background water coming from the Gulf that has a big role to play too. There's actually a paper just came out that's trying to define more about this. I haven't had a chance to look at it. I try to remember if I shared it with Taylor and you folks or not. So, so some people sometimes have talked about changes in humidity and rainfall in our region as being due to growing more corn and soybeans. And corn and soybeans, like I said, do affect what's happening around us, but they don't create more rainfall because they don't create more water. They're just recycling more of the water that's becoming available to us. The other part about the amount of humidity or more moisture in the air affects us is what happens in the way of temperatures. We're going to talk a little bit later in the talk here about what we're seeing in the way of particularly summertime temperatures. But when you have very humid conditions, you limit the amount of, or you limit how warm you can get during the day, because very humid conditions, it's very hard to warm up during the day. But conversely, it's also harder to cool down at nighttime. So when we have very high moisture conditions, that limits our daytime temperature range. We don't warm up as much during the day. We don't cool down as much at night. And that is another way that we have also affected temperatures around our region. Now, the other part I want to include on this that's really an important part, especially from a crop perspective, is connecting the two pieces with how much water is used out of a soil and how much water is in our soils. Now, typically, in a 5-foot, how much water does your 5-foot profile hold for good soils in your region? Most times that is probably going to be 10 to 12-ish inches of water that can be in your 5-foot profile, depending on your soil and how well managed it is. How much water do we need for a crop? From a corn standpoint, probably 22 to 24 inches of water is what we need to be able to produce a crop. So we need some additional, if you have a full profile of moisture in the soil, you still need some additional water that goes along the way. And this also connects with what we, what we talked about earlier, how much water is extracted from the soil by, an actively transpiring crop. If we're on the order of 2/10 to 2/500 of an inch of water on a daily basis, in a week's time, that's probably 1.5 inches or more that a crop needs to use. So we're extracting 1.5 inches plus out of the soil each week. So that even if you get 1 inch of rain each week in the middle of summer, you're still losing ground. And that's why when we have longer periods during that time of year, that's a real struggle and where we're able to tap out moisture, the moisture that we're seeing. And I left in a climograph for Burlington. I should show one for Northwest Iowa, because what we're seeing is one of our issues. I think I've got one later on. What we're seeing with one of our issues is that our average time, in the state of wetness is still that late spring, early summer is the average wettest time. But then we're seeing a drop off midsummer. And that drying midsummer combined with this evapotranspiration is putting us into a more of a problem, stressing crops in the middle of a season, and something that we need to continue to talk about and think about as we go along here. So, all right, let's jump through a couple more of these slides and let's get to more of where we are with current conditions. I guess, let me pause there. Are there any questions or other things people would like to ask about, or any of Josh or Taylor, anything else you want to add about this from the ET standpoint?
Dr. Todey, we've talked a lot about corn and soybeans, but what about the trees in our urban forests and around our farmstead? How does that evapotranspiration work with them?
Taylor or Josh, did you, when you put these together, did you run across anything related to trees?
I did not. However, I will add that to my list of things to add.
And I mean, we know that trees also transpire a lot of water. They also have more extensive root systems, so are able to extract water from a larger area. So most times, well-established trees are able to deal with these dry conditions generally easier. New trees always are things that we're concerned about and want to try to make sure that we get water on, especially when they're getting established. We know we've seen this kind of issue. Josh put together an issue, a publication on Christmas trees, some of the issues with Christmas trees. And establishment of Christmas trees during drought years tend to be real problems related to that. So it's establishment of new trees that are generally the bigger issue. Anything else? Give me one more shot of taking a drink. Okay, let's go ahead and hit on current conditions where we are right now and some of the issues that we are seeing and may see as we're going on to this year. So we always do that because we can talk about what the outlooks say, but we need to know where we are right now, because what the outlooks say can influence, can be somewhat influenced by the situation we're currently in. As in going into last growing season of 2024, we had very dry soils. If you remember coming out of last fall, going into last spring, I said during all my talks last year that I really expected there to be carry on drought issues into the growing season. And there were into the early part of the season, but then we wiped that out in June when we had the very heavy rainfalls leading to the flooding in northwest Iowa and some other places. But then we started getting dry back after that, and we'll talk about that as we go along here. And the drought issues have returned because of that. So we've still got drought hanging around, though we didn't quite carry through like I was expecting to last year. And that is one of the issues with extremes that we continue to see, is things that we wouldn't normally expect to happen are happening in the way of extremes overall. So where are we the last 30 days? We're total precipitation, left-hand side, percent of normal on the right-hand side. Remember, anything red or the darker reds are drier, anything that's into the greens and purples are wetter. So not a lot of precipitation overall in the plains and in Iowa. It's been wetter in the Ohio Valley, which is related to La Nina. We'll talk about here in a little bit. From a percent of normal standpoint, very dry Minnesota up to the eastern Dakotas. We've had a couple systems in South Dakota, Missouri, and up the Ohio Valley that have made it wetter than average overall. And the lake effect snows have been actually fairly effective because of the cold on the warm lakes. But contrast this then if we go back just 4 months to where we are. This was from the latter part of September on. If you remember, we were very dry for the end of our growing season into the harvest season. The scale on the left-hand side is kind of messed up because there was a wetter area down here in Kentucky and Tennessee that throws the map off. But focus on the percent of normal. You know, some of that wet area has gone away as we look back the last 4 months, so that, you know, basically everything from, you know, the Nebraska-Kansas border through central Illinois, Indiana, and Ohio, everything north of that was dry. You know, Nebraska and the Dakotas much drier, you know, less than half of average over the last 4 months, while the southern part of the region has been wetter than average overall. So we still have some drier soils I mentioned that I mentioned getting to earlier. Let's see. One of the other things looking back at last year too, this is again related to some of the temperature issues. I left this in. This is Sanborn, data from Sanborn in northwest Iowa from a talk I did last week, because it applies pretty much for the whole state. We talked about, you know, we've talked about the last month and last 4 months. So this looks at 2024 as a whole. And one of the things that we continue to see looking at our growing seasons, I mentioned earlier, is this kind of lack of extremes. This is a graphic for Sanborn, and this is daily data from January 1st of 2024 until the present. The blue bars are the high and low temperature each day. And you want to compare those to this brown line in the middle. This brown band, the top of that brown band is the average high temperature for each day. The bottom of the brown band is the average low temperature for each day. So any of these places where you have the blues well above the line, those are very warm periods. And then when it's below are very cold periods. You don't see a lot of very cold periods, except for around this same time last year where we had, you know, a week to 2 weeks of cold, and then we rapidly went to very warm throughout the rest of the winter and early spring. We had some warmth in April, but then not a lot of extreme warmth through the middle of the growing season. You know, some moderately warm time periods. And that's again related to this humidity issue we're talking about, that we're fairly humid, we don't warm up as well, but then we also don't have very cool periods overall. And in fact, the extreme warmth doesn't come back until the fall. For those of you that are Iowa State football fans, you know, if you remember the late October day where we hit 90 degrees, so it was rather unpleasant being out tailgating, but it was a lovely evening in latter part of October. And it wasn't until the last game that we finally had some cold overall. And that is, again, that same kind of issue I mentioned about. This is for Northwest Iowa, the climate division in Northwest Iowa, comparing our long-term trends in summer temperatures. So June, July, August averaged high temperatures in the upper left-hand side and low temperatures in the lower right-hand side. And each one of the dots is a year from 1895 to 2024. So the average highs, and then the blue line is the long-term trend. A lot of variability here, but really kind of flat overall in the way of trend, and maybe slightly declining depending on how you look at it. Low temperatures, on the other hand, are doing something quite different. A lot of variability, but much warmer nights. We don't cool down as much as we used to. And that is, somewhat different from what we've seen during the daytime. So that does have issues from a livestock perspective as well as a crop perspective, that we just don't see, those cool nights that is better for crops overall. It's also harder on livestock, that our heat events that we experience tend not to be extremely high heat. They tend to be warmer days with very high dew points, and then you don't cool down at night. So from a livestock perspective and a human perspective, we don't get that cooling at night to ease some of the stress on us. So we're seeing more overall issues with livestock related to this, seeing a variety of experiences with this. We've seen extremes to Kansas a couple of years ago, where we saw several hundred or several thousand head of livestock because of some early season warm and humid conditions that ended up impacting livestock. All right, where are we with soil temperatures right now? Fred and I were talking a little bit about this before we came on, and what we're seeing recently is not a surprise to us. The red numbers here that you can see on here are the measured foreign soil temperatures at various research farm sites. So 1917, the warmest being maybe around 20 degrees. Here's a 28 in southwestern Iowa, a little bit warmer, but fairly cold foreign soil temperatures. This does not surprise us. One, we've had very cold temperatures. Two, we've had limited to no snow cover to help insulate the soils. And three, I'll show you here in just a minute, we have very dry soils. So we were not surprised that frost depths started going very deep. And in fact, we'll move to the next slide here to show you how deep the frost depth is going in various places around here. This is a National Weather Service map where they actually have gauges that some automated weather stations measure temperatures at different depths. There is a separate gauge that tells you at how deep into the soil we have frozen conditions. So this ranges from southwestern part of the state maybe down to 6 inches, middle part of the state maybe around a foot, most of the state probably around a foot, and then as you go further north, it gets even deeper, 2 to 3 feet in some cases. Now, the problem with that is, one, if you don't have water lines buried deep enough. I think Fred was mentioning that somebody he knew, they were having to do a lot of work because water lines were not buried deep enough. So that the frost depths were going deep enough, we were freezing water lines. Two, this pops up with water main breaks. We fully expected this to happen when we have cold outbreaks like this. There was one on my street as I returned from last weekend where there'd been clearly a water main break. So that was not a surprise because of the extreme cold and overall dry soil moisture conditions. Here's a couple different products that show what our soil moisture situation is like. And these are soil moisture percentiles. Basically that same color scheme. The darker the orange, the red is, the drier we are compared to this time of year. Anything that's in blue on the upper left-hand map or green on the lower right-hand map are wetter than average. And we really don't have much showing wetter than average, maybe a little bit in Wisconsin, where there's been some additional precipitation. Most of the eastern Corn Belt and even parts of Iowa, especially northern Iowa, still are running on the overall dry side comparatively. So that combination of frost depths really did not surprise us overall. And then one other thing I threw in, I left this map in, I showed this map last year. This was up until around this time last year. How much, how much of a departure from normal, or how far below normal we were over the last 3 years, the last 36 months. So much of the state, except for maybe a little pocket up in the Northwest, was running 16 to 20 inches short over the last 3 years going into that time period. And you could see that Iowa was kind of the center of that focus. We extended out into a little bit some of the states around us, but we were the focus of that. And I was just curious then, I said, well, okay, let's incorporate this year and then go the last 4 years. And you see, it really hasn't changed an awful lot. We're still in that same situation, except for the heavy precip area of northwestern Iowa, where they're actually a little bit above average for the last 4 years now. Still, a good chunk of the state is showing these overall dry conditions. And this is probably popping up in the way of groundwater levels because they've been tapped out in many areas. We see this when we stop getting rainfalls, stream flows tend to fall off because there's just not as much water in the hydrologic system as there should be. Now, we don't have to make this whole, we're not going to make this all up before we say we're completely out of drought, but it is a consideration that we're looking at in many of the issues related here. So speaking of drought, let's go ahead and look at where we are, looking at the U.S. Drought Monitor. On the upper, this is last week's map. This week's, let's see, today's Wednesday. This week's map is being prepared, being finalized right now, will be released tomorrow morning. This is valid as of, so the map comes out Thursday morning, it's valid as of Tuesday morning. There has to be a cutoff time where we can say we're not incorporating any more data, so that any rainfall or precipitation that occurs after that time period has to be considered for the next week. So on the left-hand side is where we are nationally. Not too bad overall, but still decent amounts of dryness around us and drought issues in the central part of the U.S., more so in the northern plains. On the lower right-hand side is a zoomed-in map of Iowa and the north central states. So much of northern Iowa is still in that D1 moderate drought. A little bit of area just north of Sioux City is considered D2 severe drought, connected to some places out in the plains area here. Much of southern Iowa, we've moved to that white, which is considered no drought overall. We've had enough precipitation that we've considered no issues on the U.S. Drought Monitor. Here are the how much we have changed on the Drought Monitor map over the last month. Winter time is a slower precipitation time overall, so we don't move the Drought Monitor very quickly one way or the other because we don't expect a lot of precipitation. You have to be drier than average for a fairly long period of time before we worsen. Though we are taking note that, from Iowa northward, we've kind of had a snow drought where we've had precipitation but not had much snow. That's led to the issues we saw with freezing soils. It's also been a problem with people who like to recreate and have snow. There's just not been very much around overall, and especially these northern areas that expect to have snow and have recreational opportunities based on that, they're seeing some issues related to that. Okay, let's bob through these here and let's go ahead and get us to where we're headed. The big issue is that if you've heard me comment over the last 6 to 9 months or so, we were talking about the potential for getting into La Nina and a rapid transition out of the El Nino last year to La Nina. It kept looking like it was going to happen, looking like it was going to happen, looking like it was going to happen, but never did. Finally, last week, 2 weeks ago, NOAA officially declared that we are in a La Nina. Conditions have changed appropriately. So here's how we define that. We're looking at sea surface temperatures in the Central Pacific and Eastern Pacific along the equator. The area in blue is areas that are colder than average on the sea surface temperatures, and that is one of several indicators that we go to. And these are incorporated into indexes, the couple different indexes that we show on the right-hand side here. The more blue we're seeing in this is indicative of finally being in La Nina conditions. So we are now officially what's called a La Nina advisory. We are in La Nina. So we can incorporate that into thinking and into the outlooks, and that's going to influence the outlooks I'm going to show you here. We don't expect it to last very long. We don't expect it to affect our summer at all, maybe a little bit of spring. And it will not have a major impact, but it does give us a few things that we can talk about overall. So let's bop through here and jump to our outlooks. Okay, we're going to show you outlooks now that come from NOAA, the National Weather Service. We base everything we say on what they can say and then do an interpretation from them. We do at the Midwest Climate Hub create an ag outlook where we take basically the same information that we've shown you here and put this into an outlook that was updated. And we just updated one a couple weeks ago, I believe. We'll probably be working on one here as we get into the first part of February. The outlooks are updated. The ones for 6 to 10 days, 8 to 14 days are updated daily. I encourage you to look at those because they are an indicator when you can see big cold outbreaks or warm-ups coming. And also, if you're in dry periods or wet periods, how that may be looking in the near term, just beyond what the National Weather Service lists for their 7-day forecast. Okay. So next 7 days for precipitation. We've gotten out of the cold. It looks like fairly moderate temperatures as we're going along for the next 7 days overall. 7-day precipitation, we do have, you see over Iowa, some light green. There is going to be probably a little bit more light snow, but not a major issue at all with lots of white around us. The main player right now is down in the Gulf, where yes, there was snow, and Louisiana had blizzard warnings yesterday. Believe that or not, Louisiana had blizzard warnings. Taylor had gone to Auburn. She noted there was a couple inches down there, and I think as much as 8 inches of snow or more in some of the places down there, which is a real problem for them. And lots of cold throughout the eastern part of the U.S. This cold didn't affect us. It affected the whole eastern part of the U.S. And that's a real problem down south because it's harder for them to deal with it. There's also ag crops that are impacted by severe winter cold. Okay, jumping ahead to the 8 to 14 day outlook, temperature on the left-hand side, precipitation on the right-hand side, and all these next maps are going to be that same way, temperature on the left, precipitation on the right. So the darker area here indicates that as we go through the rest of the month into early February, likely near or to above average temperatures. So not seeing much in the way of more severe cold at this point. And then hints overall towards the dry side. Not strong, but hints towards the dry side. The more active pattern is the Gulf up to the Ohio Valley and then areas to the north of us. So not a lot of additional precipitation coming. So these were updated last week, the 30-day outlook for February. Again, same thing, temperature left, precipitation right. And these are more La Nina looking. Hints towards the cool side for February overall. It looks like we do have some more cold coming as the month goes along. So we lean towards the cool side for the month as a whole. On the right-hand side, precipitation, very La Nina looking precipitation. The Ohio Valley and Great Lakes have a better chance of being wetter during a La Nina. So Iowa and especially areas to our east have a much better chance of precipitation. So those dry areas to our east have a better chance of recovery. Also for some for us in the state, partially depends on how the precipitation falls and what our soil temperature conditions are like. Can that water get in the soil or will it just be producing runoff? The outlook for February, March, April, so this gets us into planting season. You see very much a similar kind of thing. Less chance for cool, and we move to the white, which is equal chances. It doesn't mean average. It means we just can't say one way or the other as better chances for being warmer or colder. And then still hints towards the wetter side as we go along into the spring. So this could lead to more chances for delayed spring activities in the wetter areas here, less chance for Iowa and areas to the north and west of us. And then by the time we get around to summer, La Nina becomes not a player. So we're a lot of what we can say around summer is based on the trend information that I've been talking with you about already. So our long-term trend in summertime temperatures is flat. So really not saying much in the way of temperatures overall. There are hints. I mentioned about this midsummer drying, and I think I skipped over the follow-up graphic, that we have seen some more midsummer dryness occurring, and that increases our chances for being dry this summer for much of the state. Now, note, there's been some things talked about with a 2025 drought coming. I'll be clear and upfront with this. We do have risk of drought this summer, but it is not any kind of an increased risk or any kind of an increased risk of major drought. But that's, we don't see any indications that there's any kind of a larger risk of big time drought this year. So we do have this midsummer drying that we've known about and we've been talking about. So that's something we need to incorporate. But we don't see any major potential issues forthcoming overall. Okay, quick summary. Colder after, I didn't talk about this, we're really quite warm around Christmas time. We started freezing soils early and then overall warmth around Christmas and have been colder more recently. Still this longer term dryness that we're dealing with that we've been able to alleviate some, but not completely. We did have, precipitation in November that really helped our soil moisture situation. Otherwise, it would have been a much worse situation than we are right now. And then we are in La Nina, so helping drive current conditions along with various climate change issues. So again, La Nina is going to continue to play into the rest of winter and early spring, and then kind of go away after that. We still do have drought issues from here northward, particularly to the Northwest Corn Belt. What we can see from a spring planting standpoint, we're probably appropriately dry in northern and western Iowa up to the northwest part of the Corn Belt, where we have less of a concern with spring activities. That it's unlikely to be wet enough to be a problem there. Again, eastern Iowa to the east, we have some bigger chances of some spring, the spring wetness slowing some things down a little bit. Right now, not major concerns, but something we should keep an eye on. And then we likely La Nina goes away and we just go, latter part of spring and summer, we have to focus on trend at that standpoint because we just can't put enough information on that far enough ahead at this point. So just a couple other quick things to talk about. If you like hearing updates related to, to near-term conditions like this, we do a monthly webinar series with regional climate services partners, NOAA, National Weather Service, and state climatologists. It's free. It's 1 o'clock on Thursday afternoons, 1 o'clock Central Time. You just have to go sign up. You get a chance to listen in, ask questions if you want to, and you can go back and listen to the recordings later. Another product we rolled out this year is we have gone state by state talking about climate issues in each state and what's going on in ag in each state, how the climate is changing in each state, how that's being impacted, how ag is being impacted. Josh was a big driver behind all of these. This is the one for Wisconsin. We also rolled out the one for Iowa. So you can get to the QR code, or there's a link on our website to all of these. Along with these, we're also developing some various crop-related issues related to climate and whatever that crop is. We've got one on Christmas trees. We've got one on fruit trees just came out. I keep thinking one along with dairy is something we probably want to work on somewhere along the way. And they're basically follow the same thing. Where are the dairy areas in the region? What is going on in the way of climate that is impacting them? How are they being impacted? And then what are some things that you can do to start dealing with that related to those climate issues? So if you're interested in that, we should have more of a conversation related to that. And then I mentioned our Ag Focus Outlook also on our website. If you want to get on our email list, you'll get emails when any of these things come out and are updated. Again, we do this at least once a month, sometimes more frequently. That again, what are the current conditions? What are the outlooks? And what does that mean for various agriculture in the region? And I'm going to, since we're getting closer to the end of the hour, jump through these. And here's our website. And I got to take that CCA credit thing off. I did that for one of my talks, and I keep forgetting to pull that out. So here's our website. Some of our folks, again, some other of our folks sat in and listened to this today. So you can ask them other questions if you want to. But thanks for being here. I appreciate the chance to get out and chat. Hopefully there was some usable information, and I'm happy to talk more about things or answer any questions that you have.
Thank you very much, Dennis. Appreciate all the information. I'd like to remind folks, if they scroll back up on the chat box, we have it'll be archived at our website. And then there is a short survey. And I know everybody is being surveyed to death, but this really does help us when we are building programs, webinars for the future. So please do that. We're a small enough group. If you want to just unmute and ask us a question, we'll give just a few seconds to see if that happens. While folks are putting their questions together, Dennis and crew, is it really getting more windy than it was when I was a kid? I don't remember these 30-mile-an-hour winds day after day, but is that just an old man not remembering, or is that happening?
Actually, I should let Josh answer this one. We have dived into this somewhat in trying to understand what's going on in the way of wind related to ag, and then just understanding overall wind trends. Part of our problem is we don't the way we measure wind has changed somewhat over time. Prior to the 1990s, there were wind, there were anemometers that were sighted the same way as they are now. But there was an observation just before the top of the hour that was someone looking at a gauge and saying, well, here's what I estimate that wind speed to be within the last X number of minutes. We now have better electronic ways of measuring that over time, so we can see how, we have more details about how they're changed. So it's hard for us to talk about trends over time. I think overall there's not a lot of variability we've been able to notice. There may be some more shifts in extreme winds and stronger winds, but again, the data are a little bit harder to come by. We don't have historically as many measurements as we do now. So it's a really hard thing for us to try to get at. And you think with the technology that we have, we should be able to do a better job. And I agree. But, as I mentioned, prior to 30 years ago, some of the data that we have is not as detailed spatially. We don't have as many locations. Temporally, we constantly have information out there now. So it's harder, and some things there's questions about hail. We've had questions about hail, and we really can't even answer about that because we don't have ways of measuring regularity of hail. It's all based on people observing hail and reporting hail, which has a whole other set of issues related to it.
Okay, I'm not seeing a question in chat. Don't see anybody unmuting, so I'll continue to ask questions. A couple of years ago, we had a discussion on we're seeing more severe weather events. Is that trend still continuing, or was that a fluke?
No, that is very much something that is showing up. I didn't include that graphic. NOAA, National Oceanic and Atmospheric Administration, has a count of billion-dollar disasters. They do inflation-adjusted billion-dollar disasters, and our billion-dollar disasters are continuing to increase all across the country, and we're seeing them across the globe also. So we are seeing bigger events, more damage done to the events, and kind of more shifting of extremes also. So both of things are coming to play in the way of, heavier rainfalls is part of it. Stronger winds at times are part of it. There seems to be more hail, though again, we don't have quite the same data related to that. So yes, we're getting more damage because of that. And that is something that is right in line we expect to see with climate change. With more extremes, more variability, and bigger events doing more damage to agriculture and impacts because of that. So it's something that we are continuing to see and will expect to continue to see. If we want to hold this mantle of it, it's not a proud one to have. The 2020 derecho is still the most expensive, most damaging severe weather event. Now, severe weather events are not defined, that leaves out tropical systems. They're different. That's a different set of things. That 2020 derecho was the most damaging severe weather event in U.S. history because of the widespread damage to buildings, to crops overall. There was a huge amount of damage done to that. And that's one of the examples of things that we've started to see more of.
Okay. We're reading about disastrous forest fires in western part of the country in California. When we had these forest fires in Canada, that brought a lot of smoke on us and had some micro changes in our weather. Are we going to see that same situation coming because of the fires in California?
That it's very unlikely. And that question keeps coming up. I need to throw in that graphic of there is a National Weather Service website. Josh or Taylor, any of my folks, if you can find that and drop that in the chat. Is it AirNav? I can't remember which one it is, that can show you where fires are and smoke coming from them and expected issues. It's a really nice graphic. The impact of the fires is astounding locally, and the impact to air quality out there locally is terrible. Will it have an impact on a wider spread basis like over here? Extremely unlikely, because for as damaging as they are, they're not nearly as widespread as we saw in Canada and some of the Western US in some previous years. You have to have forest fires over a large area that are occurring for a long period of time, and then you have to have the right atmospheric conditions and winds to blow them the right way to cover us. So we saw them very well at that time because of the air quality effects we had around us and some of the changes in sunrises and sunsets and some of the blotting out of solar radiation. But I don't think there's going to be enough smoke from these that's going to occur on a wide enough basis to be able to impact us here. Again, locally, it is a very serious situation for them, but I don't expect to see much of an impact from us overall.
Okay. Again, we'll wait just a second, see if we get a question from the audience.
I should say, while if there's any more there, we are certainly always willing to talk about more of these issues in detail. If there are specific types of information or things you'd like to know more about, some of these questions that come up, we'd like to know more in detail about that. Give us a call, send us a note, because that's one of the advantages we have with some of our additional staffing now, is that we can dive into a few more of these things and help share information about them that is out there either in published literature or to try to find out more information about that. Or if there's a tool or a type of information, is this kind of data available or this kind of outlook? talk to us, because sometimes we can create it. Sometimes we can talk to our partners and they can help create it. That's one of the great things we've been able to develop across the Midwest, in Iowa and around other states, are really great collegial relationships that help to serve the whatever stakeholders we're trying to reach, and what their needs are.
Okay, my final question is going to come, it'll be a cow question. With the open, well, kind of a cow question. With the open winter and that relation to soil temps, is the potential for alfalfa crowns heaving this early spring going to be worse or normal?
Gosh, and I was just thinking I needed to read about alfalfa crowns. Certainly, and I glossed over this part of it. Thanks for bringing that back up. One of the other concerns we have with open winters is any fall seeded. Usually think about winter wheat, winter rye, whatever like that. The cold could damage those. The frost situation with frost heaving, I could certainly see an issue related to that. I don't have a lot of expertise in the physiology of alfalfa, but these frozen soils certainly I think are gonna come into play with some various plants, because we have had deeper frost depths, and we'll probably bounce around some more. As I mentioned, we're going to get warmer, and then it looks like we still have some more cold coming in February, so we're going to go through that cycle again, and then probably a few more cycles through as we go through in the springtime.
Well, thank you very much, Dr. Todey. A lot of great information here. And I want to give a special shout out to Taylor. Man, you'd mentioned something and that person has fast fingers. And we've got a lot of great stuff there in the chat box, and I appreciate that for folks that are going to be watching this in the archive. So again, go ahead.
Yeah, we love, we've been trying to corner the market on ag climate people in the Midwest for the last couple of years. We're Josh and Taylor are both happy to have, and I guess I should call out Sophia's an undergrad finishing up this spring, and then Moses and Christine on there are some of our evaluation folks who are helping evaluate some of the work that we're doing. So it's an enjoyable time to have these folks on board, and I'm happy to say that I'm leading them, though I'm just acting in a figurehead. They're the ones getting work done.
Well, sometimes I've discovered when you have good people around you, it's best just to stay the hell out of their way. That might be the best way. So again, thank you and your crew. We had a great program. I appreciate it. I appreciate the folks who joined us today, and we look forward to having you come back and see the program next month.